Hello everyone, I am Shobha Nikam, Assistant Professor in Department of E&TC Engineering of AISSMS Institute of Information Technology Pune. In this video, I'll describe reliability of satellite equipments. We should calculate the reliability of a satellite subsystem for two reasons. The first is we want to know what is the probability that the subsystem will still be working after a given time period, and we need to provide redundant components or subsystems. If one fails, other one will work. Where the probability of a failure is too great to be accepted, the owner of a satellite which is used for communications expects to be able to use a predetermined percentage of its communications capacity for a given length of time. Purchase and launch costs will be calculated on the basis of an expected lifetime. And of course, expected lifetime must be as large as possible. The manufacturers of satellite must provide their customers with predictions or simply a guarantee of the reliability of the satellite and subsystems. And to do this, it is needed to use reliability theory. So reliability theoretically is a mathematical attempt to predict the future and is therefore less certain than other mathematical techniques that operate in absolute terms. The application of reliability theory has enabled satellite engineers to build satellites that perform as expected at acceptable construction costs. And you should note this, the cost of a satellite is very high compared to other equipment with a comparable number of components. And this cost is acceptable because of high revenue earning capacity of the satellite. So, reliability of a component can be expressed in terms of probability of failure after time t. For most of the electronic equipments, probability of failure is higher at the beginning of life, the burn-in period, than at some later time. And as the component ages after some time period, the failure becomes more likely, and it gives graph like a bathtub. So you can see bathtub curve on the screen. So probability of failure is higher at the beginning and it is also higher at the end. And in between useful life period, it is zero or it is minimum. So components for satellites are selected only after extensive testing. The aim of the testing is to determine reliability, causes of failure, and expected lifetime. So the testing is carried out under rigorous conditions, representing the worst operating conditions likely to be encountered in the free space, and may be designed to accelerate failure in order to shorten the testing duration needed to determine reliability. Units that are exposed to the vacuum of space are tested in a vacuum chamber, and components subjected to the sunlight are tested under equivalent radiant heat conditions. The initial period of reduced reliability can be eliminated by a burn-in period before a component is installed in the satellite. So components are tested before they are installed in satellite. So initial burn-in period can be removed or eliminated. Then the semiconductors and integrated circuits that are required to have high reliability are subjected to burn-in periods from 100 to 1000 hours, often at high temperature and excess voltage, to induce failures in any suspect devices and to get beyond the initial low reliability part of the bathtub curve. Then mathematically, the reliability of a device or subsystem is defined as it is the ratio of number of surviving components at time t and number of components at start of the test period. So number of components which are not failed divided by total number of components. And number of components that are failed, they can be calculated as initially how many components were there and at time t how many components are there, subtraction of these two. But from the engineering viewpoint, what we need to know is the probability of any one of the available components failing is related to the mean time before failure, MTBF. And average failure rate, which is represented using lambda, is the reciprocal of mean time between or before failure. So average failure rate can be written as or can be calculated as number of failures in a given time divided by number of surviving components. So the probability of a device failing therefore has an exponential relationship to the MTBF and is represented by the right hand side or right hand end of the bathtub curve. The equations shown in previous slide allow us to calculate the reliability of a given device. When we know its mean time before failure, in a satellite, many devices are used, each with a different mean time before failure, and failure of one device may cause catastrophic failure of a complete subsystem. If we incorporate redundant devices, the subsystem can continue to function correctly. We can define three different situations for which we want to compute subsystem reliability. The first, as shown in the figure A, it's series connection which is used in solar cells arrays. Second is B, parallel connections. Here R1 and R2 are equipments used. R1, R2, R3 and so on are equipments used in satellites or subsystems used in satellite. Then the parallel connection is used to provide redundancy of the high power amplifiers in satellite transponders. For example, traveling wave tube amplifiers used. And a switched connection is often used to provide parallel paths with multiple transponders. These are illustrated in figure shown on the screen. Also, the hybrid arrangement, which is series parallel connection, is widely used for electronic equipments. The switched connection arrangement is also referred to as ring redundancy, since any component can be switched in for any other component. And here you can see switches S1 and S2. They are little more complicated than as shown. So they afford the choice of multiple paths in and out between input side and output side. And the important point here is the active devices here used have sufficient bandwidth, power output range to be able to handle any of the channels that might be switched through them. So reliability is an important issue in satellites, and to improve reliability, to achieve high reliability, to extend lifetime of satellites, redundancy can be used. So thank you everyone for watching this video.